Welcome to my presentation. This presentation is part of the playlist Integration by Substitution. In this presentation, we will be solving problems related to integration by substitution. Let us look at some examples. Let us say we want to evaluate an integral, um, the square root of 1 minus 3x dx. So we're going to use the integration by substitution to solve this example problem. Let us substitute u as equal to 1 minus 3x, the term under the radical term, which is 1 minus 3x in the given problem. So we're going to substitute u as equal to 1 minus 3x. We're going to differentiate u with respect to x as shown here. So du by dx is equal to the differential of a constant is 0, so we don't need to write that. The differential of minus 3x is minus 3. So du is equal to minus 3 dx. We can get the dx, which is in the denominator here, to the side of the negative 3 term. And we can write it as shown here. Du is equal to minus 3 dx. We want to write it in terms of dx. So dx is equal to negative 1 over 3 du. So I just rewrote this one as shown here. Dx is equal to minus 1 over 3 du. Now we can substitute u as equal to 1 minus 3x and dx as equal to minus 1 over 3 du into the given example problem and solve it using the integration by substitution method. So let us see how that looks. So the given problem is integral square root of 1 minus 3x dx. So wherever we see the square root of 1 minus 3x or wherever we see minus 1 over 3x, we're going to substitute u for that. And since that is under the radical term, we're going to put a radical term over u like that. Integral square root of u. And then instead of dx, we can write minus 1 over 3 du. And that's what we were mentioning. That's the reason why we rewrote this as shown here, dx as minus 1 over 3 du. So we have successfully substituted all the terms. Now we need to convert the radical term into an exponential term to be able to integrate, to be able to apply the integration process. So square root of u we can write as u to the power of half. So once we have it in an exponential form, we should be able to integrate it using the rules of integration. So instead of square root of u, I'm going to replace that by u to the power of half, and then the next term is minus 1 over 3 du, which is like that. Now, since minus 1 over 3 is a constant, I'm going to take it outside of the integration process, minus 1 over 3 integral u to the power of half du. So now we are ready to integrate each of these terms. Minus 1 over 3 is a constant. We need not have to do anything with that. Integral u to the power of half du, we can write as u to the power of half plus 1 divided by half plus 1 plus c. Whenever we complete the process of integration, we're going to add a constant term c as shown here. So we'll simplify it some more. Minus 1 over 3, u to the power of 1 half plus 1 converts to u to the power of 3 over 2, and in the denominator 1 half plus 1 converts to 3 over 2, and therefore we can simplify it some more as shown here. Minus 1 over 3 times, we have 3 over 2 in the denominator. When we bring it to the side of the equation, that it converts to 2 over 3 times u to the power of 3 over 2 plus c. So we'll simplify it some more. Minus 1 over 3 times 2 over 3, we can multiply the numerators, multiply the denominators, and we have minus 2 over 9 u to the power of 3 over 2 plus c. We need to substitute u as equal to 1 minus 3x, and that's what we started off saying. We said let u be equal to minus 1 u be equal to 1 minus 3x. So the solution should be in terms of x, not in terms of u. So since we have simplified as much as possible, now we're going to back substitute it into u as 1 minus 3x, which is right here. So wherever we see u, we're going to substitute 1 minus 3x. So therefore, minus 2 over 9, instead of u, we're going to write 1 minus 3x, the whole thing raised to the power of 3 over 2 plus c, where c is a constant of integration. So this is the way we want to be able to solve example problems using integration by substitution. So let's look at another example. Let us say this time we want to evaluate this integral x times the square root of x squared minus 1 dx. We are going to use the integration by substitution to solve this example problem. So let us substitute u as equal to x squared minus 1, and that is the term we have under the radical term here. So differentiating u with respect to x, we have du by dx is equal to du by dx of x squared is 2x. Du by dx of x squared is 2x, and then du by dx of negative 1 is 0. So I didn't write that. So du by dx of x squared minus 1 translates to 2x, like that. So now we can write du as equal to 2x times dx. So all I did here was to bring the dx to the side of this 2x here. Now if I want to express it in terms of dx, I can write it as 1 over 2x times du, like that. Now we can substitute u as equal to x squared minus 1 and dx as equal to 1 over 2x du into the given example problem and solve it using integration by substitution method. So now our given problem is integral x square root of x squared minus 1 dx, and now we're going to substitute whatever we've mentioned. U should be, wherever we see x squared minus 1, we will substitute that by u, as shown here. Integral x times square root of u, square root of x squared minus 1, square root of u, and then instead of dx, I can write 1 over 2x du, 1 over 2x du, as shown here. Now let's look at the next step. So since 1 over 2 is a constant, I pulled it outside of the integration process. And then there is an x in the numerator, x in the denominator, they cancel out. So I didn't show that there. All we are left with is square root of u du. So all of this simplifies to 1 over 2 integral square root of u du. We need to convert the radical term into an exponential term to be able to apply the integration process. Square root of u I can write as u to the power of half. So therefore y is equal to 1 half integral u to the power of 1 half du. Square root of u converts to u to the power of half, and then I have du there. Now we are integrating these terms, so it converts as shown here. 1 half times integral u to the power of half du converts to u to the power of half plus 1 divided by half plus 1 plus c, where c is a constant of integration. So the next step is 1 half u to the power of 1 half plus 1 converts to u to the power of 3 over 2, and in the denominator we have 1 half plus 1 that converts to 3 over 2, and then we have a constant of integration c. So let's simplify this. So 1 half, which is that, and then we have 3 over 2 in the denominator. So when we bring it to the side of the equation, it converts to 2 over 3 times we have u to the power of 3 over 2 in the numerator, and we wrote that here, plus c. So we'll simplify it some more. We have 2 in the denominator, 2 in the numerator, they cancel out. We are left with 1 over 3, and then we are left with u to the power of 3 over 2. Nothing, we already simplified that. There's nothing more to simplify, and then plus c. So we need to substitute u as equal to x squared minus 1, and that's what we started to say here. Wherever we see x squared minus 1, we will back substitute it. Wherever we see u, we're going to substitute x squared minus 1. So therefore, here we have 1 over 3. Instead of u, I'm going to replace it by, or substitute it by x squared minus 1, the whole thing raised to the power of 3 over 2 plus c, where C is a constant of integration. This is how we're going to use the substitution integration by substitution method to solve example problems. In my next video presentation, we will be solving more example problems related to integration by substitution.